Okay, I'm going to do an example of applying Kirchoff's rules to a circuit. We have here a circuit that has 4 resistors and 2 batteries. I'm going to summarize here what it is we know about this circuit. We know that this resistor, the 2 resistors on the outside actually are both 6 ohms. The resistor in the bottom, in the middle, oops, I guess you can't really see that unless I move it over, is 3 ohms. Okay, and the one on top is unknown, so we're just going to call that one R. In addition, we know basically nothing about the batteries, so we're just going to call this one EMF 1 and this one EMF 2. As for the current, we know that there's a current going through this resistor here of 2 amps, and I'm just going to pick a direction this way. Now, when you're applying Kirchoff's loop rules, if you've chosen the direction incorrectly, it'll all work out because the signs, as long as you're following the sign convention, if you've chosen the wrong direction, then whatever current you're looking for will actually turn out to be negative. Okay? So, this current going through the 6 ohm resistor is given as 3 amps, and the current going through this 6 ohm resistor is given as 5 amps. The current through the 3 ohm resistor here is unknown, and so I'm just going to call that I. Again, I just picked a direction. We'll see how it works out with the signs in the end. Okay, so what are we looking for in this problem? Well, we're looking for several things, actually. We have 4 target variables that we're trying to solve for. What we want to do is we want to find this unknown R up here at the top. We want to find the 2 unknown EMFs, E1 and E2. And we want to also find the unknown current I that's going through the 3 ohm resistor in the middle and the bottom. Okay? So I'm going to start by applying the junction rule. Now, in some problems, you might want to apply this rule at every junction that you can. For this problem, as it will become apparent, I really only need to apply it once, and I'm going to apply it right there to that junction that I've indicated with sort of a dot. Okay. Now, how the junction rule works is that all the current going in has to equal the current going out of the junction, so that there's no buildup of current at that particular junction or any of the junctions, really. Another way of saying that is that if you add up all the currents following the proper sign conventions, you should end up with the sum equal to 0. So let's do that. Let's apply the junction rule, JR for junction rule, to the junction that I've indicated with a dot. Okay. When I do that, I see that I've got 3 amps of current coming into the junction. For coming into the junction, we give that a positive sign. I've got my unknown I current leaving the junction. Leaving the junction gets a minus sign. And I've also got 5 amps of current coming in, so I'm going to add that in as well. Okay, the total of these currents then has to add to 0. And then this will allow me to solve for the unknown current, and I find that it is equal to 8 amps, and so I've chosen the direction of the current correctly. Okay, so I can check off that target variable that I've just solved for. Like I said, we could go to other junctions here and try and ascertain what's happening to those, but I think it's going to be more straightforward for us to look at what's happening in various loops here. We have 3 more unknowns to solve for. which means that we would need 3 loops in order to come up with that, all of the unknown equations that we can solve for. So, and how you choose those loops is really, you have freedom to decide that. You can decide the direction of the loops. You can decide exactly which loops you want. You can go around the whole entire outside, for example, or one of these inner sections. Okay, the loops that I've chosen and the directions I've chosen are the following. I took this first section here and I went clockwise around, all the way around here, and I called that loop A. And then this loop, second loop I chose is in this section here all the way around. Okay, again, I go clockwise. I just always go clockwise to keep myself consistent, but you don't have to go clockwise. As long as you're following the sign conventions, it will all work out. And then the third loop I chose over here all the way around clockwise. I called that loop C. Okay, so I'm going to apply the loop rule to A first. And the loop rule, like the junction rule, basically means we're going to add up things and sum the total to 0, only this time instead of adding up currents, we're adding up potentials. Okay, so where you start on the loop is up to you. I generally start at a battery if I have one. In this case I have 2. I'm just going to start with the one on the left hand side. When I go through the battery from minus to plus, negative terminal to a positive terminal, then I get a positive sign there. So this is going to be EMF number 1 with a positive sign. It's the first term in my sum.